Hi folks. Up until this point, we've talked so much about absolute value, and we've talked a lot about inequalities. We've talked about them together on graphs. We've talked about them together algebraically. And so today we're going to talk about absolute value inequalities and their applications in real-world situations. So we have 3 examples today that absolute value inequalities and our knowledge that we built up over the last week or two is really going to help us make sense of. So we're going to start out with our essential question. I'm using my text tool. The essential question is, how do we write and solve an absolute value inequality from a word problem? How do we write and solve an absolute value inequality from a word problem? Now, example 1 says, when Spheres R Us ships bags of golf balls, each bag must contain 860 balls plus or minus 9 balls. Usually this is called the margin of error, so we can have more balls than 860 by 9, or we could have 9 less than 860, but 9 is our margin of error. It asks us to write an inequality which represents an acceptable number of golf balls in each bag. So the first thing that we need to do is we need to name a variable. Our variable is going to be in our inequality, which is supposed to represent an acceptable number of golf balls in each bag. So our variable should probably be golf balls. The margin of error is something I had mentioned before. It's how much you can have as kind of variance for your problem. So each bag must contain 860 golf balls plus or minus 9 golf balls. So 9 is the margin of error. Next, what are we trying to find? Well, the question said write an inequality which represents an acceptable number of golf balls in each bag. So we're trying to find the number of golf balls in each bag. Finally, we're supposed to write the absolute value inequality. Now, the absolute value inequality will have absolute value symbols, and it will also have inequality symbols. So I'm going to go ahead and use the equation tool. The equation tool is on the left side. And I'm going to move my screen over so that you can kind of see what it is that I'm doing. Now, if you click on the equation tool, sometimes nothing comes up except for this, but if you click to insert a symbol, you'll see that there are all of these symbols that you can insert, and these 4 are the ones that you want to insert the most in Algebra 2. So if you click on them, they appear at the top, and those are kind of like your most recently used symbols. So it's kind of like a shortcut for what you want to type. So I'm going to move my window back. And the absolute value inequality starts out with the absolute value symbols. So shift and then the button that's above the enter on the keyboard. So the absolute value of the number of golf balls, B, minus 860, close the absolute value. If I take the difference of those two, so the number of golf balls in the bag and the number that are supposed to be in the bag, and if I subtract them and then just take the absolute value, so the positive number, well, that's going to have to be less than or equal to less than or equal to, and I'm going to move that right here, less than or equal to my margin of error, which is 9. So my absolute value inequality is that the absolute value of the number of golf balls minus the number of golf balls that are supposed to be in there, 860, well, that's going to have to be less than or equal to 9, because 9 is my margin of error. Now, Whenever I solve, remember from a few days ago that we want the absolute value to be isolated, and it is. Absolute value of b minus 860 is isolated on the left side. So I'm going to create two inequalities. The first one will be b minus 860 is less than or equal to 9. And the second one will be b minus 860. Remember, you switch the inequality sign, so is greater than or equal to, and then you switch the sign of the 9, so negative 9. Also, move these over. Also, I need to consider whether this is an and or an or set of inequalities. Remember that you can figure that out just based on the inequality sign here. It's the less than sign, it's not the more sign. So this is not or, this is going to be and. So I'm going to type with my text box and. So whenever I solve, I'm going to do the opposite of my constant that's there, which is minus 860. I'm going to add 860 on both sides. And what I'm going to have remaining is going to be a b on the left side. It's still less than or equal to, so I insert my symbol, and then 9 plus 860 is 869. So there's one inequality. My next inequality, I'm going to do the same thing. I'm going to do the opposite of the constant, which is minus 860. So I'm going to add 860 and add 860. And once I add 860, I'll have b on the left side. I'm going to insert my symbol of greater than or equal to. And negative 9 plus 860 is really 860 minus 9, so it's 859. So there is my second inequality. Now, I'm supposed to write the solution and graph. It asks, is it less than or equal to? Or it says it is less than or equal to, so this represents an and statement. And will be shaded where? Where are and statements shaded? Are they shaded between or are they shaded on the outside? They're shaded between the two numbers. So my solution, I'm going to use an equation. My solution, my lower number is 850, I'm sorry, there's a mistake on here. Where's the mistake? The mistake is here. If you have 860 and you subtract 9, the answer is not 859, the answer is 851. So when you have your solution, and I'm glad we caught that on camera, that way you can see that your teacher makes mistakes too, especially on the end of a day. Your solution is your lower number, which is 851. 851 is less than or equal to your b values, which is less than or equal to 869. And for your shading, I'm going to use the drawing tool. So we've got two numbers. The first one is 851. The second one is 869. The symbols are less than or equal to symbols, so there should be closed points here. And because this is an and inequality, we should be shading between. Finally, I'm asked to write my answer in sentence form, so we really need to describe what's happening with the golf balls here. So in sentence form, we were trying to find the number of golf balls that must be in each bag. So our answer should probably start out with each bag of golf balls. So each bag must contain at least how many golf balls? At least 851 golf balls. But no more than how many? Than 869. So that's our answer in sentence form. Each bag must contain at least 851 golf balls, but no more than 869 golf balls. So let's go ahead and move on to example 2. You saw all the things from example 1, and it took a while, so now let's move on to example 2. Example 2 says, for a door to meet specifications at a carpentry shop, the width must be within 1/2 inch of the expected width of the door. The shop gets an order for doors that are 4.5 feet wide. Write an inequality that expresses the range of width for acceptable doors. So we need to name the variable that we're going to use. If we're writing an inequality that expresses the range of width for acceptable doors, then the variable is going to have to be what? The width of acceptable doors. What's the margin of error? How much do the width of the doors need to fall between? Well, up here it says the width must be within 1/2 inch, so the margin of error is 1/2 of an inch. And what are we trying to find? Well, the question says write an inequality that expresses the range of width for acceptable doors, so we're trying to find the range of door widths. So I'm going to write an absolute value inequality. I'm going to use my equation tool, but before I do that, I'm sorry, I don't know why it keeps scrolling. Before I do that, I notice that my margin of error is 1/2 of an inch, but the doors that are ordered are 4.5 feet wide, 4.5 feet wide. So I need to take 4.5 feet and I need to convert it to inches. How do I do that? How many inches are in a foot? 12 inches are in a foot. And if you multiply 4.5 times 12, you're going to get 54. 54 inches are in 4.5 feet. So that's going to be important because we need that number in the absolute value inequality, but we didn't have it before. We had a number of feet, not a number of inches. So if I'm going to write the absolute value inequality, I'm going to start out with my absolute value symbols, so shift and then the button above enter. My variable w, I'm taking the difference of that variable w, which is the width of acceptable doors, and the width of the doors that are ordered, so 54 inches. And that distance, that change, that difference between acceptable doors and the doors that get ordered, that change needs to be less than or equal to your margin of error, which is 1/2. So I would like for you to pause the video and try to solve this absolute value inequality, remembering that you need to decide whether this is an and or an or statement. Go ahead and check your work with the work that you see on the screen. In both situations for each inequality, you have to add 54 to both sides of the inequalities. For one inequality, you get that the width of acceptable doors is less than or equal to 54.5. And for the other inequality, you get that the width of acceptable doors has to be greater than or equal to 53.5. Remember, the solution is an and situation because the symbol is less than, not more. So we write it as a compound inequality and the shading is between those two boundary values. So I'm going to scroll down a little bit because the next thing we need is to write our answer in sentence form. So I'm going to pull up my text box. Remember that the question asked us to determine an inequality that expresses the range of width for acceptable doors. So the width of the door must be between 53.5 inches and 54.5 inches. And I should probably give units to the 53.5 as well. Wonderful. Okay, let's scroll down to example 3. Example 3 says, during 2007, Earth will travel, or Earth did travel, around the Sun along a path that is not a perfect circle. Earth will be closest to the Sun on January 20th and at a distance of 91.4 million miles, and farthest on July 7th at a distance of 94.5 million miles. Write an absolute value inequality for the distance between Earth and the Sun throughout the year. A hint is to find the midpoint, or the halfway point, between the closest and the farthest distances, and then find how much the distance can vary. So I'm going to use the number line that was given, and I'm going to see if I can kind of figure out where the midpoint is. So we have 2 points and a point in the middle. The distance that was the shortest was 91.4 million miles. The distance that was the farthest was 94.5 million miles. And I'd like to find in the middle. I'd like to find the distance right in the middle, that kind of average of the two. So what I'm going to do is find the average of the two. So if I add 94.5 plus 91.4, and I divide it, so perhaps I can draw a little line underneath. If I divide it by 2, you're welcome to get out a calculator and do that math, but that's going to equal 92.95. And of course this is in millions of miles. So 92.95 is that halfway point right in the middle. So you need to take maybe a calculator or just a moment off to the side, and you need to determine what this distance is and what this distance is. And if 92.95 is the midpoint, the middle point, that means that these two distances should be the same. So take a moment to try to determine the distance between an endpoint and a midpoint. So if you found the difference between those two, hopefully you found the difference was 1.55 million miles. So the average was 92.95 million miles, and the margin of error, how much we can go above that number or below that number, is 1.55 million miles. So let's get back to all of the parts of the question that we would typically have to answer. I need to name the variable. Well, the question is asking me to find and write an absolute value inequality for the distance between Earth and the Sun throughout the year. So I need a variable that's going to represent the distance between the Earth and the Sun. So maybe we can call that D for distance. The margin of error is how much you can kind of vary above or below your middle point. So that amount you can vary above or below is 1.55 million miles. The absolute value inequality, I'm going to have to use an equation, my equation tool. So it's the absolute value of my variable, d, and its difference with the average, the middle number, which is 92.95, should be million miles. So perhaps we should, we'll just measure this. We'll say it's the distance between the Earth and the Sun in millions of miles. That way we can keep our 92.95 and we don't actually have to type out the whole million. And that needs to be less than or equal to your margin of error. So less than or equal to 1.55 million miles. Now, it asks us for the solution, so typically we would need to solve. But in this case, if I were to solve, well, I'm already going to get those two values that I was given in the problem. So I can just use those two values to write my solution with the smaller value going first. So 91.4 million miles. Let me move that up a little bit. There we go. And that needs to be less than or equal to my variable d for the distance. And that needs to be less than or equal to kind of my upper boundary, which is 94.5 million miles. And finally, we need to write our answer in sentence form, so I'm going to write it down here. The question was, write an absolute value inequality for the distance between Earth and the Sun throughout the year. So the average distance between the Earth and the Sun is what? What was the average distance? The distance in the middle. It was 92.95 million miles. But the actual distance can vary by that margin of error. So the average distance between the Earth and the Sun is 92.95 million miles. The actual distance can vary. Not vary like a lot, vary like be different. Can vary by 1.55 million miles. And these are just some applications of absolute value inequalities. They typically have to do with the margin of error and being able to find quantities that are acceptable.